Good evening, everyone. Welcome to the Carolina Weather Group. We're happy to have you this evening. And tonight we have with us Rachael Cross and Emily Lenhardt, both students at Oklahoma, the University of Oklahoma, OU, for all you Boomer Sooner fans out there. And we know that OU is one of the big weather schools there is here in the United States. And so we're excited to have Emily and Rachael on to talk about maybe why they chose to go to Oklahoma and kind of pick their brains about what it's like there in Norman. We're also going to talk about some research they've been doing with social media and weather and the verbiage and how you better understand weather. So we're going to dive into that as well. So kind of a two-parter tonight. So Emily and Rachael, welcome to the show. We have no rundown, no format. This is going to be kind of an open discussion tonight. We want it to be fun. And so our first question to you all, which is one that we always ask every weather guest that we have here, is how did you get caught up in this weather world? When did you know you wanted to go into school and study meteorology?
Hi, I'm Rachael. I'm currently a incoming PhD student at the University of Oklahoma. And I got into weather when I was 3 or 4 years old. That's when I remember experiencing my first really severe storm. I think there was a funnel over my house. And I remember hearing the sirens, my mom rushing me to the bathroom, and I was terrified. But after the event, my mom pulled me aside and got these library books about storms and read them to me. And I was fascinated by it. And then I just wanted to be a storm chaser ever since. And that evolved into a love of mathematics and dynamics, and just combining those two passions together led me to pursuing a degree in meteorology, especially at the University of Oklahoma. That's my story.
Yeah, I guess for me, I didn't have one, severe weather event. I feel like a lot of people at OU, remember their first tornado or first severe storm that got them into weather. But I always just thought it was really interesting when I was growing up. I remember I would have this dry erase board in my room, and I would write out the forecast, draw the little symbols on it every week. And I really just loved math and science in high school and thought the weather was really interesting. So decided to go for it and go for meteorology in undergrad.
You guys have done a very interesting study on words of estimative probability, and I know I'm going to bungle that phrase at some point during this show, but it's really cool, really interesting. Before we get too deep into it, since I've already mentioned that phrase, what are words of estimative probability?
Yeah, so words of estimated probability, if you want to just acronym it, it's WEPs. That's what we've been calling them. So if you want to just say that, that's fine too. There are things that you use more often than you probably think. There are words like likely or might or chance. So you could just say, it's likely that I'll take a nap after this or something like that. Likely would be your word of estimated probability.
I'm happy to stick with WEPs. That's far easier to remember and say. So going through this study, can you tell us a little bit how you structured it? I know there are 3 core pieces. Can you tell us about those 3?
We came into this study working with Joe, or Dr. Ripberger, and he showed us results from their 2018 weather survey, which I think we talked about in the paper, where they tested these different WEPs and asked people to assign a number percentage to each one of them in a severe weather context. So we knew that he wanted to, look at how those words were used in Twitter messages. And so we started looking through almost 9,000 tweets from different weather forecast offices, expecting to, see how they use those kinds of words and phrases. And so then after that, we realized that they were using a lot more vague of terms. And so we, went through all those tweets and found the most common WEPs that we found, and ended up including those in the 2019 survey. So that we could see, how people interpreted these words that we were seeing pretty often in all of those Twitter messages.
In the process of doing that, one of the databases that y'all looked through, as you just mentioned, was the CRCM Severe Weather and Social Media Data Collection Program, which sounds really interesting. I hadn't heard of it before today as I was reading through your paper. How does that program work, and how can we access that as everyday people?
I think that's something that Joe is in charge of. I believe you can access it, through the CRCM page. I don't have the website, I don't know it off the top of my head, but if you type in OU CRCM, I'm sure there's a link to it on that page. Because I know he puts up a really nice spreadsheet and really, really pretty visuals of some of the results of some of the weather survey information that they get. So they can like co-locate it by like region and by like population count. And so you can kind of see how people have responded to these different questions that they've asked over the course of multiple years. I know that's something he was putting together as of 2 years ago. Since we went off to our own like master's thesis after that, we haven't been as much in touch with him, but I'm pretty sure it's pretty well established by now.
Mm-hmm.
So I think I've seen him use it a couple times in the past.
Yeah.
One of the things that really caught my eye in this paper right off the bat, I think it might have been in the first page, was a concept that I hadn't heard of before, severity bias. I thought that was fascinating and very applicable amongst Joe Schmo out in public as he's reading through maybe a tweet from NWS or other outgoing forecasts that talk about probabilities or words of estimated probability. What is severity bias and how is that affecting our decision making when it comes to WEPs?
So I think that was mostly referencing, it's been a while since we wrote that part of the paper, honestly. But that trying to think how to say this. If you have a better way, just interrupt me.
Okay.
But I guess just thinking about those terms or those words of estimated probability that we use in terms of, the severity of what you're trying to communicate. Those surveys that went out to see how people were interpreting these words tested a difference between, if people would associate that word with a severe thunderstorm or a tornado. And we didn't see a lot of difference between in the results between both of those two options. So
that if you have something that's very severe in terms of risk and like the impacts of the event, so something versus like, a hurricane versus like some light showers that you can go, still walk outside in, people are more apt to put a higher number with the more severe event, even if it's not as likely to occur as the less severe event. So it's the idea that you want to put something bigger to a more impactful event, even though it's less likely to occur. So it's a severity bias.
What would you think the findings what are the findings from it?
The big thing we saw in that analysis of the Twitter messages was that most of the time, in the messages we looked at, these WFOs are communicating severe weather probability using pretty vague terms. So I think we had a chart in there where, you saw that the most common one was it probably, right?
Possible.
Possible. My gosh, sorry. Was possible. In other words, like might happen. There's a chance of this. And so, we really didn't see them using very descript WEPs to communicate severe weather probability. And we certainly didn't see them using many numerical estimates of probability either.
Yeah, because a lot of past work, not necessarily in the meteorological field, but, perhaps with like the CIA or, medical institutions, they do this kind of research as well, because they also communicate probability. Like for medication, there's a probability of a certain side effect that occurs. And that's also very important. That's also where a lot of severity bias comes into play, because, if you have a more severe side effect, people might, rank or mentally rank that particular probability higher because they don't want that side effect to occur. But they do a lot of work, and they found that the best way to communicate probability is using both words and numbers together. So saying like, it's likely 50% chance that I will take a nap later. That's the best way to communicate probability, because words alone can be pretty vague, because my definition of likely is going to be different than your definition, and it's going to be different than someone listening to this later on. So we found that out of all 9,000 tweets that we looked at, only 3 tweets communicated probability using this combination. So not only are WFOs using very vague words, they're not communicating in the best way as past studies have shown.
Mm-hmm.
Yeah, the recent TikTok trend of like probability of precipitation kind of also goes into that. Everybody's got a different idea of what that means. So with this finding, and you only 3 tweets from weather forecast offices, has this information been presented to the Weather Service, or and if it has, what was their comments, or did they have any, or anything like that?
Yeah, so we've met with a couple of groups from different, Weather Service regions and different offices to kind of talk about this. I know we've talked about it at AMS too, and we're able to talk to some forecasters there, but I think the response has been pretty positive. I remember a lot of people we've talked to have, I don't know the outcome as of now, but at least in the moment when we were talking about it, they seemed really enthusiastic about, trying to start making some of these changes, either in terms of, trying to have forecasters use more specific words or I think we've even talked to some about, how they thought about the idea of like developing a list and associating, certain words with certain percentages and starting to, implement that change. So from the people we've talked to, it's been pretty encouraging that people have seemed to want to make that change in how they communicate.
Yeah, I think we've given at least 3 or 4 like seminars to different collections of weather forecast offices. So like the biggest responses come from the Southeast region, especially. They reached out and we had like a ton of their offices join in. And I think they're the ones who ended up developing an actual document for their weather services and having some sort of list and kind of assigning like numbers to that and just trying to use some of the words that we found were better or more at least concisely interpreted by the public in their language.
I think that's fascinating. How the Southeast has been the biggest advocate for that amongst the WFOs, but also how these WEPs relate to numerical probabilities. And there I go using the word probability. I don't know if this is y'all's graph. I don't think it is, but I remember it catching my eye about a year ago, or probably even more than that now. With COVID, time just kind of slips by. This was always one of my favorite charts. And if this looks totally out of place, you're welcome to just say, no, this is stupid and we'll cut it out. But I think this is fascinating. I'm sure this was generated by some survey. I have no background on this whatsoever, but it's fascinating to see how people perceive different words of estimated probability as different percentages. And there's some very wide ranges on here. Clearly, people don't interpret almost certainly or we believe in nearly the same way. And I know those words weren't necessarily the ones that y'all tested, but it just goes to show that, wow, it's really easy to guess these wrong.
Yeah. One thing that would be interesting to continue off of this study, if we had like infinite funding and time, would be to take it a step further and see what these percentages people assign actually mean. Because the ideal response from people isn't just a number in their head, it's a certain action. Right. And like it'd also be interesting to know like, well, what threshold incites some sort of protective action for them and their family and their property. Because that's, kind of what we're hoping to get at. If we're like forecasting for a tornado, well, we want to use the language that's going to incite the right response, hopefully.
Right. Oh, that would be fascinating.
And it's curious because with facets, coming down the road at some point in the ever changing probability of where a tornado may go. So that's pretty cool to see how that will link up with the words.
Yeah. It was one of the main motivations for this work too, because a lot of the weather service offices are going to be moving towards a more probabilistic forecast rather than just like, a yes, no, or perhaps even like 1-0 kind of system.
Yeah.
So I know that y'all did not specifically introduce the SPC convective outlook into your study because there were, there is a methodology to reaching those. But when people hear marginal, it's almost like, it's dismissed. And marginal days can often be our most busy days. Mm-hmm. Those can be very bad days. It's just that the chances were low, that the predictability was low. I have started to see kind of a move towards like level 1 of 5, but there's not a lot of people who use the SPC, the percentages behind that. Do you think that would be something that would be a better or perhaps more effective communication approach going forward, thinking about the probabilities there versus the categorical risks?
There are 2 things that come to mind initially, and one is you're very right in thinking that like marginal risk for certain areas typically are their busiest days compared to say like the Central Plains. Because a marginal in like Oklahoma, everyone's like, okay, yeah, that's cool. But if you have a marginal somewhere like the Northeast, that's a lot because they perhaps don't really get that. So marginals, like that marginal risk is very dependent on your location and what that means. So 1, it's dependent on location, and 2, in terms of the probabilities, a lot of those probability numbers are very low. They're not above 50%. And so if you give someone a probability that's lower than 50%, they're probably going to think, oh, well, I got like a 1 in 5 chance of it happening. That's fine. I don't have to change my plans. I don't have to get prepared or get ready. Because their percentages are not just probability. It's also based off of like spatial probability as well as like, not this temporal, but just probability of chance along with a spatial probability as well. So it's a little bit different. So I'm not sure just using the raw probability numbers or those percentages with SPC would be necessarily beneficial, but I know there has been research into how best to involve the SPC outlooks and how to communicate that. In fact, there's another guy at the CRCM, Sean Ernst. I would highly recommend looking at his master's thesis and all his upcoming work for his PhD, because he's kind of delving into that regional aspect of the SPC outlooks.
I've always told people, they ask about the weather community, and I was like, obviously we put a lot into forecasting, but with the recent rise of social media and all the different platforms, you almost have to put as much into communicating as you actually have to do into forecasting for people to kind of grasp that. And so it's almost like a 50-50 toss up. I don't want to cheat one because of the other, but they're both so important to what we do. So we appreciate the work you all have been doing. And like Jared said, it's definitely it's good to look at and see where we can better communicate those risks, especially here in the Carolinas and the Southeast. Like Jared alluded to, marginal and slight days are like enhanced and high days for you all out there in the plains, because that seems to be the days that we're the most busiest. So
yeah.
Free publicity here for OU for any student who is considering meteorology and just doesn't really have an idea of where they want to go yet.
Again, you get to see a lot of cool weather. You kind of get a little bit of everything, and you don't always know when it's going to happen, because one day you're going to get 30-degree weather and next day you're going to get 90 degrees. So you're always on your toes. But in terms of the facilities, you get to be right next to the National Weather Service. So if you're interested in forecasting, you get to know forecasters that let you walk in, like with the SPC. You just email them and they will let you just kind of sit in on one of their work shifts. You can see what that's like. If that's something you'd be interested in, they have workshops. So you can use the actual AWIP software outside of like a pathways program. So you just get to go for 4 hours on one weekday and play around with it. And they'll give you like a fun tornado case to even put out your first real but kind of fake warning. You get the whole printout and everything. It's a really great program. The faculty is fantastic. The professors are all super nice and friendly. And I mean, I'm partial to the grad student body because that's what I'm in now, but I feel like it's really easy to find friends too. That's the biggest thing for incoming freshmen. You kind of walk into a sea of like 5,000 plus new people, and it's a little intimidating. And with the weather community, it's really tight knit. So it's a really good place to be.
Norman is close to, more in Oklahoma City. So kind of thinking from that perspective, like there is stuff to do here, even though I know some people feel like, Oklahoma's middle of nowhere. We do have a few things to do. University is, big, but not, super overwhelming, especially like Rachael said, once you get into meteorology, like, we all pretty much know each other. So that makes the university feel a lot smaller. I guess also in terms of research, I feel like a lot of people associate OU with severe weather, which is true because a lot of severe weather research happens here. But we have a lot of faculty doing a lot of different things, climate research. I do like aerosol stuff. Mesoscale, there's like all kinds of research.
Social science.
Yeah, social science. So I feel like basically whatever area of like meteorology you're interested in, you're probably going to find someone doing that kind of research. Or even if, you just want to talk to them about it, not necessarily do research. There's just a lot of different stuff going on here.
Going to Oklahoma, it's a bigger school and arguably the biggest meteorology program in the nation. Was that intimidating in any way?
I think it was exciting. Like I was really excited for it. And that's one of the reasons why I think I went, because I knew they were, one of the top schools in the nation for meteorology. I had kind of personal ties to the school because my dad went to OU as well. And also they're kind of, right in the middle of Tornado Alley. And I knew they did a lot of research on severe storms and severe weather. And that's kind of was my draw. So I guess I was so excited about the severe weather. I didn't really think about how big the program was.
Yeah, I remember I was not intimidated before I got here really, but I think once you get into the program, it can be intimidating. I remember for me, at least, there are every year, a lot of freshmen who come in really excited, which is great, but I really didn't know anything about weather. And so it's very like an odd experience to come into a bunch of students having, a lot of background information and background knowledge, which is great. But I remember that was kind of intimidating, but other than that.
I'm curious, when you guys were trying to decide, was Oklahoma your only choice, or did you go to other schools and visit? And if so, what kind of lured you in? I know the National Weather Center there, just pristine and pretty cool place to be if you're a weather nerd. So what kind of lured you or made that final decision to choose OU?
Yeah, so I toured and applied to, I think, Western Illinois University, which is pretty close to where I grew up, Texas A&M, and then KU. And so I think I just really knew, like, when I visited the campus, I knew that I was like, this is a really cool place. I was like, this feels, it feels like a good place to be. The people I met with in the meteorology department were really enthusiastic, which was a difference from some other meteorology departments I met with. But yeah, and then I guess the other thing was just like all of the opportunities here, which I probably didn't necessarily realize when I, was applying and decided to go to OU, but just like there's so many research opportunities. And like you said, the National Weather Center has so many different like weather entities within it. I think I, had a vague grasp of that coming in, but that was definitely a big factor too.
Yeah, and I knew back then she was a sophomore or junior, and she gave me like a special tour of like the weather center and the campus that was very tailored to like meteorology students. And she gave me a lot of insight into like these extra buildings around the weather center that, house like different forecasts, little like, spin-off offices and like, weather news that works really closely with like Japan offices. And so there's a lot of like collaboration. In fact, where I work now is the Radar Innovation Lab, which is right across the street. And they do a lot of like radar research and stuff like that. So there's so many different opportunities within the building and also really close outside the building as well. And so hearing about that, I was like, well, this is a really great job, like opportunity, kind of really easy tie into like a potential job after undergrad. Cause she also told me they typically hire undergrads at OU, which is really great. So.
So as you progress through your freshman, sophomore, junior, and senior years at OU, I'm sure mentors played a huge role in your success. Can you talk a little bit about how you found mentors for yourself and just how they helped you, not just through the undergrad process, but as you move towards graduate and now a PhD program?
Yeah, I remember in our first like real meteorology class, I think it was back then called Intro to Meteorology 1, but I remember going to office hours a lot because I had like zero confidence in anything I was doing. I was like, I want to like pass this class and like do well. So I was like always in that professor's office hours. I think it was like every single week. I thought she was going to get sick of me, but I got to know her really well. And I think she could tell that like I didn't come in necessarily with like a career goal and like a long-term goal of what I wanted to do in meteorology. And so after that class was over, she had an undergraduate like research opportunity open up. And so I was able to like continue working with her after that. And that was super great. She also, encouraged me and like the rest of our class to apply for like the Hollings program and different scholarships like that. So I'm really glad I went to those office hours all that time, or else I don't know, if I would have as easily gotten like an opportunity like that. So that was super helpful for me.
What made you decide to go to grad school? What took you from, going to setting foot on campus at OU to, hey, I've got my bachelor's degree, or I'm about to have my bachelor's degree, to, at least in Emily's case, relationships between lidar aerosol extinction, backscatter coefficients, and CCM number concentrations during the NASA Oracle's campaigns?
You can go ahead.
That's a great question. I think, honestly, when I came into undergrad, I was like, I want to be done in 4 years. I was like, I don't want to go to grad school. I don't want to do research. I think that's honestly just because the thought of that really scared me and I didn't really know what that meant. And so getting those research opportunities during undergrad, I was like, this is really interesting. Like I could see myself continuing to do this. I wasn't super enthusiastic and like really wanting to go towards like the broadcasting route. Oh no, I guess forecasting broadcast. I didn't really want to do that, but I knew that I really enjoyed research. And so honestly, the whole process of like applying for grad schools is kind of a whirlwind that kind of happened really last minute, honestly, for me. But I think it was really those opportunities during grad school where I was like, I really enjoy research and I could see myself like continuing to do this in the future.
Yeah, my story is very similar because I came from a community college to start with just to save money. And so it took me 6 years to get my bachelor's. So by the time I got to my senior year, I'm like, I'm extra done. I don't want to do anything else.
Yeah, I can relate. It took me 9 years to go from high school graduate to bachelor's degree.
Yeah, and I really appreciate being able to go to 2 different institutions and meet lots of different professors and make those connections. But by the end, you're definitely experiencing some burnout, and I definitely was. But what drove me to grad school was doing that undergraduate research. I realized I loved that process of just discovery and kind of that interaction between like people and researchers. Like, I don't know, you also get to interact with like other students. So it's kind of like this almost not weird, but like it's a very unique dynamic. You know, it's kind of like a modern day like apprenticeship almost. So you get really, really close with your advisor and also your other coworkers and other students. And eventually there's kind of like a hierarchy, like you have your advisor, your grad students and your undergrads. And even as being a grad student, you get to be mentors to the undergrads. And I just really liked that dynamic and I was really drawn to that. So it was still a last minute decision. I remember we were both in like the atrium of the Weather Center, like within like November, trying to study for our GRE and everything and get that sent in. But it was the undergrad research experience and then just kind of the dynamic with your advisor that really drew me in.
So being at OU, I mean, you've got to have some storm chasing stories, right? I mean, there's storms everywhere. Even if you just go up on the observation deck and just kind of look out at what's around. I mean, any fun or any exciting storm chases that you guys have been on?
So honestly, you see a lot just even by being in Norman. It just kind of comes to you.
That's
it seems
true.
like.
I think there was one in 2017, one semester. There was a small tornado that went along Highway 9 right south of the Weather Center. I remember we were in the Weather Center because usually a lot of meteorologists go to the Weather Center on the first floor, like a lot of students whenever there's severe weather, because 2 of the classrooms serve as bomb shelters / storm shelters. So a lot of people go there, but then they have like these big screens and people just kind of like share their screen. Everyone's watching radar. Everyone's has like different, NWS chat discussions up. So it's kind of like a mini
storm party.
Yeah, it really is. It's like a sleepover storm party in like a classroom. So it's kind of a fun time.
Yeah.
I'm going back to 10 years ago me, and I'm telling myself that there is a much more fun way to do college.
I mean, I think we need to pack up and go to Norman next time there's some storms out there. That sounds fun.
Yeah, just bring some pizza or something and, we'll let you in.
Rachel, I feel like Evan and I were out with when you were out with tours, because we were out in Kansas the first week of June, I believe.
Yeah, we must have just missed. I think by that first week of June, we were burning out and heading towards Colorado in snow.
Yeah. Yeah,
we were in the snow on June 3rd.
That's true. Yeah. We were kind of in the same area.
I want to ask Rachael a question since she's a radar geek. Aside from phased array, what's the next big thing coming in radar?
I'm partial to phased array. That's my favorite of the upcoming radars because I do research with tornado debris signatures. That was my master's thesis. So the idea of a polarimetric phased array mobile radar just speaks to my heart. So that's my favorite thing. But I do have a colleague who's working on some bistatic radar. So it's a passive radar. So for those who don't know, a radar is something that, shoots out in electromagnetic waves. It bounces off of something, it comes back, and then you interpret that signal that you get back. A passive radar is something that just receives a signal. So this is something that can be used to fill potential gaps in radar coverage in a cheap way. That way you can get some extra information, especially in like areas like the Southeast, where you have a lot of mountains that perhaps don't give you that low level coverage that you need. So I'd say that's probably the next big thing, but it's still very early in development. But again, phased array radar is my new favorite thing because we're having the ARC has new mobile phased array radars coming out, the Pear and the Horus. One's at C-band and one's at S-band. So I'm very excited to be working with those in the future.
Yeah, sounds good. And in the Carolinas here, we'd be very interested in the bistatic radar just because we have such a big gap here. It would be nice to be able to fill that gap cheaply.
Yeah,
I was gonna say we'll go ahead and volunteer. We'll be.
That's right. Anytime you want to do some research here, we got some barbecue and shrimp and grits for you.
Great.
Well, Rachel, you started with you get to see a lot of cool weather. And I think that in and of itself is enough to draw any Met student in. And then all those other reasons on top is just the icing on the cake. So OU is certainly a wonderful school. We appreciate y'all sharing your experience and telling us, as well as our listeners, a little bit about the life of a student going from high school all the way up through grad school.
Well, ladies, we appreciate your time. Rachael and Emily, thank you so much for joining us tonight. We appreciate all that you've done in this research, and we want to wish you the best of luck as school's about to kick off for the fall semester. And anytime you have any new research or anything you want to talk about, let us know. We'd love to have you back on the show.
Yeah, sure thing. Thanks for having us.
No problem. And thank you all for watching the Carolina Weather Group. We'll see you soon.